Hi everyone, we're here today with a video on trapezoidal rule. So let me just read this paragraph to you to kind of focus us on what we're going to be doing. We began Chapter 5 by estimating area trapped between a function and the x-axis. To do this, we constructed rectangles under the curve, calculated the areas of these rectangles, and added the areas together. The trapezoidal rule does the exact same thing, but instead of estimating area with rectangles, we use trapezoids. Okay, so the next few pages, we're going to derive the trapezoidal rule. And I'm going to do it using some older information. So take a look at number 1. You already know how to do this. Sketch f of x equals 6 minus x on the interval 0 to 5. Then estimate the area trapped between f of x and the x-axis by using 5 left-hand rectangles. So we've done this before. We know how to do 5 left-hand rectangles, so I'm going to go through this pretty quickly. Okay, so if we graph this first and foremost, okay, so I'm going from 0 to 5. So from 0 to 5, I'm going to plot some points. So f of 0 is 6 minus 0, or 6. F of 1 is 5. F of 2 is 4. F of 3 is 3. F of 4 is 2, and then f of 5 is 1. So I just have this linear function with a slope of -1 and a y-intercept of 6. Then I'm going to go ahead and close off from 0 to 5. So here's the section I'm working on. And they want me to use 5 left-hand rectangles. So by now we know we need to find our delta x. Delta x, b minus a, over n. So 5 minus 0 over 5 is giving me that nice sub-interval length of 1 unit for every rectangle. Okay, so I'm going to go ahead and section that off. 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5. Left-hand rectangles evaluate the function at the left side of the sub-interval. So 0 to 1, I'm going to pull up on the 0, come across and down. So you can see I'm overestimating here. 1 to 2, come up on the 1. And just continue this process all the way through. There they are. 5 left-hand rectangles. Okay, so my total estimated area is going to look like the following. Well, first, we know our first rectangle here has a delta x here, or a base length here, of 1, and a height of 6. So I'm taking 1 times 6. To that, I'm adding the area of the next rectangle, which is a 1 by 5. To that, I'm adding the next rectangle, which is a 1 by 4. And the next one, 1 by 3. And eventually here, the last one, 1 by 2. Pretty simple. Now what I'm going to do is I'm going to generalize this, because I am trying to derive a formula eventually, so I'm going to try to generalize this a little bit more. I'm going to say that instead of 1 times 6, what I'm really taking is my change in x times my initial y value. Now I say initial because 0 is my initial x, so 6 must be my initial y. Plus delta x, I'm going to call my next y value y sub 1. Plus delta x times the next y value, which would be y sub 2. Continuing on, delta x times the third y value, or actually I should say y sub 3, which is actually the fourth y value. And finally, delta x times y sub 4. Okay? And the last thing I'm going to do here, each of these terms has a delta x in common. So I'm going to factor out a delta x, which will leave me with y sub 0 plus y sub 1 plus y sub 2 plus y sub 3 plus y sub 4. So I want you to kind of box that in. This is my left-hand rectangle estimated area. Okay. Flip the page. Number 2. It says sketch f of x equals 6 minus x on the interval 0 to 5, same area. Then we're going to estimate the area trapped by using 5 right-hand rectangles. Again, we've done this before, so let's do it again. So let's start with our linear function. We're going from 0 to 5, and we know it's 0, we're at 6, and then we decrease by 1 as our slope brings us down. Okay, section this off, and let's draw. We know our delta x is 5 minus 0 over 5, or 1 again, and so we're going to draw 5 right-hand rectangles. So here we go. First rectangle from 0 to 1, we'll evaluate f of 1, come across and down. So we're underestimating here. From 1 to 2, we're coming up across, 2 to 3, 3 to 4, 4 to 5. Okay, so here are my areas. That first area, so let's get a gauge on this, my total estimated area will equal. That first rectangle is a 1 by 5, because I'm pulling up here and my height is 5. The next one, 1 by 4, 1 by 3, 1 by 2, and 1 by 1. So I'm just going to add those in. 1 times 4, 1 times 3, 1 times 2, and 1 times 1. But, like I did earlier, I'd like to make this a little bit more generic. So what I really have here is I've got delta x times y sub 1. Remember, my y sub 0 was actually up to the 6. So my first height here that I'm finding for that first rectangle is my y sub 1. And I'm just going to continue this across. Delta x times y sub 2 plus delta x times y sub 3 plus delta x times y sub 4, and finally delta x times y sub 5. And last but not least, I'm going to factor out the delta x, which leaves me with y sub 1 plus y sub 2 plus y sub 3, plus y sub 4, plus y sub 5. So I want you to box this in. This is my estimated area using right-hand rectangles. Okay. Last piece for this first video is number 3. We're going to sketch it again. F of x equals 6 minus x on the interval from 0 to 5. So here we go, up to 6, decreasing by 1. And creating this guy right here. Okay, but look what it tells us to do now. It says then estimate the area trapped by using 5 trapezoids. Okay, 5 trapezoids. So for that, okay, so we're not making rectangles, we're making 5 trapezoids. 5 being the key word, so my delta x is still 5 minus 0 over 5. So what's going to end up happening is my height of each trapezoid is going to be 1 unit. Let me show you what I mean. So if we go from 0 to 1, okay, to make a trapezoid, you're going to pull up on both. So f of 0 brings you to 6, f of 1 brings you to 5, and you now have yourself a trapezoid. See that? You pull up on both sides of your subinterval. And there's your first trapezoid. The area of that trapezoid, so this is going to be my total estimated area. It's actually, because it's linear, it's going to be the true area, but we'll say estimated because our functions are not always linear. This area, now we have to remember, formula for a trapezoid, half the height times the sum of the bases. So, our first trapezoid will be 1/2 times the height, which is 1. Look at the height here. It's 1 unit. So 1/2 times 1 is just a half, times the sum of the bases. My bases are 6 and 5. So 6 plus 5. Bingo. Plus, my next trapezoid will run from 1 to 2. It will pull up here and here. There's my next trapezoid. The height again is 1 unit, so half of 1 is a half. Sum of my bases, 5 and 4. Third trapezoid, 2 to 3, coming up, there it is. Half times 1 is half, but now my bases are 4 and 3. Fourth trapezoid, here it is. 1 half times 1, and now we've got 3 plus 2. And finally, my very last one right here, again, it's going to be half times 2 plus 1. This is going to actually give you my true area. If it was quadratic, cubic, quartic, it would be an estimate. Okay, let's generalize. Here we go. My first generalization is going to be that this one right here on the top that's creating the 1/2 is my delta x over 2. So my delta x is 1. So 1, 1, 1, 1, 1. So I have delta x over 2. This is the same thing. Let me be a little bit more specific here. If you have 1/2 times your height in the formula right here, and I'm saying my height is delta x, what I'm saying is half of delta x. That's what is delta x over 2. Okay, so delta x over 2 times 6 is my y sub 0, 5 is my y sub 1. Okay, plus my next one. It's another delta x over 2, and now it's y sub 1 plus y sub 2. And I'm just going to keep this going. Plus delta x over 2 times y sub 2 plus y sub 3. Plus delta x over 2 times y sub 3 plus y sub 4. Plus delta x over 2 times y sub 4 plus y sub 5. And now I'm going to do a little bit more algebra on this to give me my final estimated area to be. I am actually going to pull delta x over 2. I'm going to factor that out of each quantity. So delta x over 2 times, and then here's all my leftovers. Y sub 0 plus y sub 1. Plus y sub 1 plus y sub 2, plus y sub 2 plus y sub 3, plus y sub 3 plus y sub 4, plus y sub 4 plus y sub 5. And if I combine like terms, my final answer will be delta x over 2 times y sub 0, 2 y sub 1s, 2 y sub 2s, 2 y sub 3s, 2 y sub 4s, and 1 y sub 5. I want you to box this in. This is your trapezoidal rule. This is not left, not right. This is your TR, your trapezoidal rule generalized formula. So tune into the next video for more on the trapezoidal rule.